All right. We want to do replacements with sine and cosine. So since this already is cosine, I'm going to leave it alone. I just tend to put it over 1 if that's the case. And I need for you guys to stop talking while I'm talking. Okay. Big fraction bar, and then we can replace cotangent with cosine over sine. Now, when you divide by a fraction, you multiply by the reciprocal. So I'm going to keep this the same, change it to multiplication, and we're going to flip this over. So it's going to be sine over cosine. And again, the whole point of changing everything to sines and cosines is that hopefully something will cancel, which it does. And so your final answer to the whole thing is just sine of theta. And again, if you want to change the theta to an x, that's fine. I don't care. If you want to leave it out as you go along, as long as it ends up in your final answer, that's good. But if you leave it out of your final answer repeatedly, I'll have to take off something for that because there should be something there. All right, see how this one says squared? That means a twin. So if you can hold this in your mind, you don't need to write it, but I wrote it twice so that I can see it. Again, if you can use your imagination to kind of hold that in your head, then that's okay. And we're just going to multiply it all together. So 1 times 1 is 1. The outsides give you sine theta. The insides give you sine theta. So what is that going to be all together? Yeah, you're 2 of them. Good. 2 sine theta. And then sine times sine is sine squared. So that's all this first part. And then it's minus sine squared. So then what is going to cancel out for that? Yeah, your sine squareds cancel. And so this part is just your answer. And again, if you aren't sure how far you have to go, hey, Miss Cole, am I done is a totally valid question to ask while taking the quiz. I will tell you, yes, you're done, or no, you need more steps. Good.
If I know like theta and like the answer, if we miss writing a theta while we're solving it.
Yeah, as long as it ends up in the final answer, I'm good. Okay. Now, when you see the 90 minus, that is a co-function identity. This is why I harp on about you saying them correctly. You're either going to add or remove a co. So how do we say this one? Cosecant. So if you remove the co, it's secant. Good. So secant of theta, I'm going to put a little dot. This one is sine. So if you add a co, it is cosine. So again, if you're saying them correctly in your mind, then you're going to get that. Now I'm going to replace secant with 1 over cosine. It's sine, and I added a co.
Oh, it doesn't have a co.
You either add or remove a co. If there is a co, remove it. If there isn't, then add it. Does that make sense?
Yeah.
All right. And then I'm just going to write that as cosine over 1. What happens there is the cosines cancel and you literally just end up with 1, which is cool. I kind of like when that happens. All right, here we're going to do our replacements. What can we replace cotangent with? Yep, cosine over sine. I'm going to put a little dot. Cosine, I'm going to keep what it is. So I'm just going to put it over 1. Gigantic fraction bar. And what can we replace cosecant with? Yeah, 1 over sine. Good job. I think I'm going to stop and take a step back and be like, hey, look, I did all that work. Hopefully something will cancel, and it does. The sines are going to cancel. Now, the cosines don't cancel. You would need 1 on the top and 1 on the bottom. So instead, we're just going to multiply them together. And so cosine squared is your final answer. Now, these next ones that say verify, it's the exact same thing you just did. It's not any different, except the answer's on the paper. Isn't that cool? Kind of like you have an answer key, right? So we're going to start with the left side, and we're going to do work until we get the right side. Now, when you see a negative, that's your even and odd. The even ones turn positive. The odd ones turn negative. Tangent is odd, so it's going to turn negative. So negative tangent theta, and then cosine theta is just going to stay. What would you try and do next? I've walked you through a few of them. Let me ask you, what would you do next? Yeah, perfect. So it's going to be negative sine over cosine. I'm going to write the cosine over 1. Again, if I'm not changing something, I tend to just put it over 1 so that I have that there. Cosines cancel. and you get negative sine of theta, which lo and behold is what this says right here, the answer is. So again, this is no different than questions 1 through 4. It's actually easier in a way because you have the answer there. So looking at this one, what can we replace cosecant with? 1 over sine, good. Minus, and then what can we replace cotangent with? Cosine over sine. Oh my gosh, they have a common denominator. Isn't that convenient? We're going to just put it together. So it's 1 minus cosine over your common denominator, which lo and behold is what the paper says the answer is right there. I kind of like these. The answer is right there on the paper. It's like when I give you the quiz, there's also an answer key. You just have to do the problems. All right, I see a bunch of squareds here, so let's look at our Pythagorean ones. I wrote them on the board behind me. They won't be there when you take the quiz, but I wrote them up there for today. We've got cosecant squared minus 1. So here's that's how they got it. Cosecant squared, if I subtract over the 1, you can replace that with what? Yep, cotangent squared. And then it's over cosecant squared. I'm going to just do one thing at a time. Now we're going to try and replace it all with sines and cosines. So cotangent squared, you can replace with, yeah, it's cosine over sine. There's just squares. That's all. Cotangent is cosine over sine. It just throw a little squared in there. Gigantic fraction bar. And you can replace cosecant squared with 1 over sine squared. Good, it's 1 over sine. There's just a squared is all that is. And then hopefully stuff will cancel, which it does. The sine squareds cancel, and so you are left with cosine squared, which is what the paper says the answer is. Go team. I think the ones on the back, yeah, the ones on the back are what you're going to need this little half sheet for. When you take the quiz, I'll give you all your own individually. Just for the sake of today, I just gave one per group and we can all share. All right. These are the ones you don't have to memorize. And we're not going to do question 9. Did I put this on yours? I guess it is. We're only going to do one of these. I didn't think we needed to do 2. We're just going to do, there's only 1 on your quiz. I thought 2 was overkill. Go ahead. I gave you 1 per group today, but what did I just say? Everyone will have their own on the quiz day. All right, so we're going to draw a picture for 7 pi over 6. What quadrant is that going to be in? Third. Good. Draw a triangle in quadrant 3. Your reference angle is pi over 6. That is the little slice, what goes across from the small one. It was just a little quiet in here. Did you say a half? Okay, a half. That means the other side, square root of 3 over 2, but they are both negative. Cool. We've been doing this forever at this point. All right, and then we're going to draw a picture for pi over 3. That's in quadrant 1. Do not eat a third of pi. That is a lot of pi. Across from that, you get the bigger side, which is the square root of 3 over 2. Other side is a half. If you want to label them A and B, you can, because on your little identities sheet, it's going to say A and B. You don't want to do that. That's fine. All you have to do is be able to read. We want the one that says sine and has a plus in it. So that is this first one right here. Do you see this? All right. So it is going to be something times something plus something times something. I am a big fan of set it up blank. Something times something plus something times something. And all you have to do is read through this and use your little pictures that you drew that are your quote unquote work, right? So the first one says sine of A. Look at A. Which one of these is sine? Yep, the negative 1/2. Good job. Reading along, I'm just pointing to it. Look where my finger is. Now we're on cosine of B. So you're going to look at this one. The X, which is a half. Very good. Plus, I already put my plus in there. Cosine of A. So we're looking at this one. That would be perfect. And then sine of B, square root of 3 over 2. And then you just have to sort that out. When you multiply fractions, you multiply the numerators, you multiply the denominators. So for this, negative 1 times 1 is negative 1. 2 times 2 is 4. I know this says plus, but do you see how there's a negative there? It's going to be plus a negative. So I'm going to just go ahead and write minus. What is square root of 3 times square root of 3? It would just be 3, right? And then 2 times 2 is 4. So if you put that together, negative a fourth minus 3/4 is -1. But oftentimes they come out to something weird, like square root of 2 minus square root of 6 over 4. Do you get what I'm saying? If you get something weird, just leave it alone. Okay? It's going to be okay. That one turned out to -1, but if it comes out weird, just leave it alone.
Go together.
Yeah, because these ones happen to go together. But if you get something that doesn't, then just do nothing, you know?
It would be negative.
Yeah, and you could put that together like -1 and -3 is -4 over 4, and then you still get -1. However your brain does it is totally cool. All right, this comes right out and tells you quadrant 3. So go ahead and draw your triangle in quadrant 3. I'm going to call this A. Now we're back to SOHCAHTOA because this is not on the unit circle. Tangent, that's your TOA. That's opposite over adjacent. Now I know this is a positive 7/24, but that's because both of these are negative. I made it a locker combination one, and it will be on your quiz too, just to keep things simple. It's 7/24, 25. Good job. I think I made the one on your quiz 3, 4, 5 because it's non-calculator. The only other one would be 5, 12, 13. I wouldn't give you a bigger one than that. All right. Now we're going to look at our sheet. We want cosine 2a. So that's right here. You could use any one of these versions of it you want. I just always use the first one because it's the first one. Are you looking where I'm pointing? Just got to be able to read. It's going to be something squared minus something squared. So I'm going to set it up blank. Something squared minus something squared. It's hard for me to keep all of this up here at the same time. Getting a little cluttered. All right, so the first part is cosine. Using your picture, cosine is adjacent over hypotenuse. Yeah, I may need a calculator for this. Again, on your quiz, I made the numbers smaller and you won't need a calculator. I know 25 squared just because that's one that I know, but I don't know 24 squared. All right, and then it's minus sine. So sine is opposite over hypotenuse. So it'll look like that. Now, when you square a negative number, it comes out what? Positive. Okay, so I just typed 24 squared in my calculator. It's 576. I'm just going to throw the question out there and see what I'm going to go fishing. Does anyone know 25 squared? I just want to see if anyone knows it. 625. Good job. Minus. Now it's minus because of this negative. When we square -7, that's going to come out to just 49 over 625. And then if I subtract those, it's 527 over 625. Again, I just threw that in my calculator real quick. On your quiz, it'll be small enough numbers that you won't need it.
Sorry, if it's smaller numbers on the quiz and we can simplify it, should we, or just leave it?
Yeah, but it'll just go together like that. Like if it, for example, if it's 3, 4, 5, what's 5 squared? Your denominator will be 25. You're going to get something over 25. All right, last one. Quadrant 1 comes right out and tells you. So draw your triangle in quadrant 1. Again, we're back to SOHCAHTOA because it's not on the unit circle. Tangent is opposite over adjacent. And so our other side of the hypotenuse is 13. And again, for these, you just need to be able to read. You just have to be able to find it on here. It says sine of a over 2. So do you see that right here? Don't put plus minus. It's in quadrant 1. It's just going to be positive. So draw a big square root. And then underneath, it's going to be 1 minus something over 2. So it's going to look like this. And that something is cosine. So looking at your picture, what is cosine? Yeah. So 5 over 13. If you're writing with pen, you can scribble it out. If you're writing with pencil, you can erase. I want to change the 1 to 13 13ths, or if you can hold that in your mind, you don't need to necessarily erase it, but then subtract. 13 minus 5 is 8. So you have 8 13ths over 2. If you divide by 13 and then divide by 2, you have divided by 26. Kind of think of a pizza that you divided into 13 slices, and then you divided each of those 13 in half. So you can feed 26 people, and they would each get like a minuscule piece of pizza. All right, 8/26 reduces. They will both divide by 2. So it'll be 4/13, almost there. What's your square root of 4? 2. So it's 2 over square root of 13, and then rationalize. So your final answer is going to look like that.
Is this stuff on the